Today we are going to discuss an important topic in chemistry, energetics. This will help us understand how energy changes during chemical reaction and why some reactions occur naturally while others do not. Heat is energy transferred between objects, while temperature measures how hot or cold something is. In chemical reaction, heat can be released or absorbed. This is what we study in thermochemistry. In thermodynamics, we study a system. A system is the part of the universe we focus on. Everything outside the system is called the surrounding. For example, a reaction in a beaker is the system, and the air around is the surrounding. There are three types of system. Open system exchange both energy and matter. Closed system exchange only energy, and isolated system exchange neither. Also, homogeneous means same phase, while heterogeneous means different phases. The state of a system is defined by properties such as pressure, volume, and temperature. We describe reaction by comparing the initial state before the change and the final state after the change. To compare reaction fairly, we use standard condition. Standard pressure is 1 atmosphere and temperature is usually 298 Kelvin. For solution, concentration is 1 moles per cubic decimeter. Under this reaction, we use symbol delta H standard, delta G standard, and delta standard. Extensive properties depend on amount, like mass and volume. Intensive properties do not depend on amount, like temperature and density. Dividing an extensive property by amount gives an intensive property. Chemical processes can be spontaneous or non-spontaneous. Spontaneous reactions occur naturally, while non-spontaneous reactions require energy input. Also, some properties are reversible, meaning they can go forward and backward, while others are irreversible. In endothermic reactions, heat is absorbed from the surrounding, therefore delta is positive. A good example is the melting of ice or photosynthesis. In isothermic reaction, heat is released to the surrounding. Here delta is negative. Combustion reaction like burning fuel and common examples of exothermic processes. Enthalpy is the heat content of a system at constant pressure. We cannot measure absolute enthalpy, but we can measure the change in enthalpy, written as delta H. It is calculated as the enthalpy of product minus reactant. In summary, energetic help us understand that energy changes in chemical reaction. By studying enthalpy and type of reaction, we can predict whether a reaction will occur and how energy is involved. This knowledge is essential for both exam and real-world applications.